Okay, I'm going to continue on with the review for this second exam here. This is the third question, and it asks us to determine the intervals on which this function is concave up, the intervals on which it is concave down, and the location of all the inflection points. To determine concavity, we're going to need the second derivative, and so when we take the first derivative, we get x squared minus 4x plus 3. Then when we take the derivative of that, we have 2x minus 4. To find the intervals of concavity, we're going to need the partition point. In this case, it's just one point, and partition number. And so to do that, set the second derivative equal to 0 and solve. So we add 4 to both sides here, divide both sides by 2, and so x equals 2 is our only partition point. There's a number line, a blank number line on the exam where you can plot that partition point, and I've drawn a sort of a barrier line here. And then you choose, as we have before, you choose a point to the left, or a value to the left and a value to the right to evaluate the second derivative. And the best choices are 0 and perhaps 3 or 4. And it's very easy to do for a linear function. Plug in 0 here, and 2 times 0 is 0 minus 4, so that's negative, and so that means that everywhere in this interval, then the second derivative will be negative. And then if we choose, let's say, 3, well, we evaluate the second derivative at 3. 2 times 3 is 6. 6 minus 4 is 2. Positive 2, so that's positive, so the second derivative is going to be positive everywhere on this interval. Now, the only inflection point is going to occur at the partition number, and so you evaluate the function, not the derivative or the second derivative, but the function at 2. So I place a 2 in here, and after I've done all my arithmetic or plugged it into my calculator, then the value I have is 2/3. And that actually should not be an x, that should be a y. So our inflection point is x is 2 and y is 2/3. Now as for the intervals of concavity, because the second derivative is negative for all values of x in this interval, then the function is concave down on that interval, negative infinity to 2. Because the second derivative is positive for all x's greater than 2, everything in this interval, then the function is concave up on this interval to infinity. And again, we use the curved brackets because it is neither concave up nor concave down at 2. And so 2 is not actually included in those intervals. Now, just to let you know what your exam will look like, I do give you a blank number line to fill in with any pertinent values, as we just did. And then I also leave you a blank to fill in the intervals of increase or concavity, and I have the notation there, and all you have to do is to use the correct bracket interval notation to complete the answer. Okay, now let's take a look at question 4. And question 4 asks us to use all the information that we gathered in the first 3 questions to sketch a graph of this function. Now I'll call your attention to the fact that I have that I've represented the function as it was presented in the first three questions, and I've represented it in factored form. And as I say here in this statement, I've presented the factored form so that it's easy to see what the x-intercepts are. You can see that when x is 0, then this whole expression is 0. And when x is 3, 3 minus 3 is 0, and 0 squared is 0, and so that makes everything, that makes the value of the function 0 as well. So that means that we have x-intercepts at 0 and 3. So you can plot those 2 points. And the only other point we probably need to plot here is the local maximum that we found in a prior question, the 0 of the first derivative. And when we substitute that into our function, we find a function value of 4/3. So 1 cubed over 3 minus 2 plus 3, that's 4/3, or 1 1/3, 1.666, not terminating. And so there's that point. And then the only other things that we need are increase, decrease, increase. We have those from the question 1, and then intervals of concavity. The function is concave down up until we get to positive 2. It's concave up afterwards. So I'm not looking for artwork. Just a sketch of the function will do. All right, now in question 5, we have been given all of this information without having to calculate it ourselves. And this first chart that you see right here is is a sign chart for the first derivative. It shows the first derivative is positive from negative infinity up to what looks like probably 1, and or rather negative 1. And then from negative 1 to positive 1, the first derivative is negative, but then beyond that, it's negative. Now, if you look in your textbook, on page 644, questions 61 to 64 make good practice for this question, and they will have there will be a 0 right here at these two locations, negative 1 and 1. That means those are critical numbers, and that means that we're going to have either a local maximum, a local minimum, or perhaps an inflection point. Then here we have the second derivative, the sign chart for the second derivative, and this shows that the graph is concave down from negative infinity to 0, and concave up from 0 to 1, and then concave down, because of the negatives here, from 1 all the way to positive infinity. So to graph this function, we have a table of values here, and that's what these red points are. X is negative 2, y is 1, function value is 1, so that's this point. And when x is negative 1, the y, or the function value, is 3, and so that's this point. And each of these points is plotted here. And we have intervals of increase and decrease here, so the function increases until we get to negative 1 and 3, right there. Then it begins to decrease, and it decreases for the rest of the graph. And the extra bit of information that tells us what to do here, where the graph is still decreasing on the left and the right of this point, is the concavity. So this section right here is concave up. It may not look like up, it's concave right, but if you were to sort of finish this bowl, then you can see why it's concave up. Similarly, at this point and to the right, you might think, well, it's concave left. Well, it's a little more obvious here that it's concave down, especially if you imagine finishing this bump, finishing this upside down bowl. And so that shows concavity that is concave down. This tells you how to draw your graph. Now, question 6 asks us to find the absolute minimum and maximum on these intervals. On your exam, you'll only have one interval. I won't give you two. There will only be one, and you won't have as many points to evaluate. There will only be 4, I think. And to find the absolute maximum and minimum, follow those steps that were given in the handout Monday, or maybe it was Wednesday of last week, because Monday was July 4th. We weren't in class. And they tell you to find the first derivative and find the critical numbers, and then evaluate the function, not the derivative, but evaluate the function at the endpoints of the interval and the critical numbers in between. So, to find those critical numbers, we take the derivative. This derivative is just using the power rule, 4x cubed and negative 36x. Now, when you set this equal to 0 and factor to find the critical numbers, don't forget, you're not just factoring out a number. There is an x that is common to both of these terms, so be sure to remember to factor out the x, or perhaps an x squared or an x cubed, or whatever is common to those two terms. So I factor out a 4x, and that leaves behind an x squared minus 9. That's the difference of two squares, and that's why this factors is like it has. And so our critical numbers are 0, negative 3, and positive 3, and those are identified here. And then if we evaluate the function at the endpoint, negative 4, and the critical numbers, negative 3, and 0, and 3, and the other endpoint, 4, then we'll have several values here, and our absolute maximum is the largest of those values, which for this case is at x equals 0, so it's 32 is the absolute maximum at x equals 0, and we have two absolute minimums of negative 49 at negative 3 and positive 3. I evaluated here at 1 because it's one of the endpoints of this second interval, but you'll only have one interval, and so you won't need to do that. And that's all for this video. We'll get to the word problems in the next one.